triangles, just redraw the diagram. 10, 5, this was 25, I believe, right? That way you don't mess up and forget what are the values you got to work with on the other one. Because now to solve for angle A, when you subtract everything out from 180, you're going to get either 109.75, or over here you're going to get 50 and a quarter. Okay. Now, reuse the law of sines to find little a here and here, and that'll give you all your possible values you can get. Sine of 10 is the 5. Sine of 109 is 2, little a. So when you solve that out for both of those, you get 27.1 or 22.14. And that's how you work with the ambiguous case. Remember, if you're ever given an acute angle and the side opposite it, check that B sine of the angle to work and see if you wind up with two triangles. Okay? Now, of all of those, but remember there was like 6 different scenarios you had to worry about with the law of sine stuff. Really, this is the only one that people forget about. Because a lot of times when you're working with the law of sines, it's going to be pretty obvious that you're going to have no triangle. Because an angle, a smaller angle, or excuse me, a large angle can't have a small side across from it. Things like that. You should pick up on that rather easily. It's the weird case, the ambiguous case, when you're worrying about the double triangle. What else would you like to look at on this? 50, okay. What's 12 plus 5?
17.
What's 8 plus, what was it, 8 plus 3 on the other one?
8 plus 5, 13.
Okay, so there's your two side lengths. I couldn't remember the numbers. So again, if the rope is 8 feet and you're 5 feet, what does it make the whole amount? 12 and 5 is 17. Use the law of sines to find theta. What's the side opposite theta? Did I say, I meant cosines, thank you. I meant law of cosines. So 26 squared is 13 squared plus 17 squared minus 2 times 13 times 17 cosine of theta. $119.55. And there's theta. The whole idea there is you just had to add those two parts together to get the side theta. What else we got? What's that? You guys do okay when you had all, I mean, there was a couple other in there that had the two, all 3 side lengths, and you just had to find the angles to get out of it. Were you all right on that?
Yes.
Okay. Remember, I think it's like number 35. When you do that, when you find an angle, what's the first angle you're going to find in this case? And why are you going to find angle B? Okay. So as you fill through, you know that 51 squared, 48 squared, plus 36 squared minus 2, 48, 36, cosine. This is B, right? you wind up getting 73.2 for angle B. Is everybody okay with that? Is that acute or obtuse? It's acute. What should you check? Yeah. Check it real fast. You got an acute angle. You know the angle and you know the side opposite it. If I know this value, if I check it with the 36, 36 sine 73.2, is it smaller than 51? But is it smaller than what's the other side? 48, or excuse me, 36? Well, but I mean, does this work?
No.
No. So you know you're only going to have one triangle. Does that make sense? What I did here is I'm just checking that B sine of that, just to make sure that these guys don't accidentally throw a second triangle at you. Okay. It only takes a second to double check it. I don't think any of the cosine problems had that. To be honest with you.
I don't know either.
I don't think it did. If it was a law of sine problem, it probably had one like that. Okay. Well, let's continue the discussion then. I'm not going to take this one because we're quizzing over this kind of junk tomorrow. What I want to do here is go over. What were you doing before that?
Softball.
Okay. What I want to do with this, though, is I want to add to it because there's another way to solve for the area of a triangle if you don't have that side angle side scenario. It's called Heron's formula. So let's look at it. Heron, yeah. Like Lake Huron?
Oh, I thought you said
I think that's like a slang pronunciation of heroin.
It is. And I'm glad you picked up on that.
Why do you know that? Heard a couple rap songs.
Kind of looks like the
All right, this is really, really, really weird for something that is very simple. Here's what you do. You're going to be given a triangle that has side lengths of, I don't know, 2, 11, and 9.
What is this called?
Heron's formula?
Just like here.
Yeah. But it's H-E. Isn't Lake Huron H-U?
Yeah.
Whatever. I have a degree in math, not spelling, so it's all good. No, it's unbelievable, isn't it? So here's what you do. This value S is called the semi-perimeter. What does semi mean? Half. So what you're going to do is you're going to find half the perimeter. So what's 2 plus 11 plus 9?
21.
2. 22.
22.
So you wind up with 2 plus 11 plus 9, and you cut it in half. So what's 22 over 2? 11. All right. Now, to find the area, since we don't know bases and heights, we're not drawing in angles, we're not drawing any of that out, what we do is we take that value of 11, and then we just take 11 minus 2, 11 minus 11. Wait, did I screw something up?
Yeah, you just say
What? It shouldn't be 0. I don't know. Oh, this might not be able to make a triangle, that's why. That's what happens when you make up numbers.
Yeah, that's what I was wondering.
Sorry.
Wait, yeah, it's 9 and 2.
Yeah, it wasn't going to work with that triangle. All right, let's look at it with something we all make sense. What kind of triangle is that? What's the area of that triangle? 6. Very good. You did 1/2 base times height, correct?
Yeah.
All right. Now, it's a 4.
It's a 7.
What I'm saying here is we know how to find the area of a right triangle given all the sides. Works the same way. What's 3 plus 4 plus 5?
12.
Divided by 2, you get 6. Now, to use the same idea of the formula, you'll take 6 times 6 minus 3, 6 minus 4, 6 minus 5, and you might be pleasantly surprised at your answer. You can type that.
36.
Again, just type it right in your calculator.
It's going to equal 6.
It's crazy how that works, isn't it?
I got an error.
You did something wrong. It works the same way. What happens if you type that in your calculator? You just gotta watch your parentheses. It will work real fast.
So does it, does it only work for that, like for triangles, or
If you know the
answer?
Yeah, if you know, no. If you know the 3 side lengths, it works every time. Okay? If you know the 3 side lengths, it'll work every time. Let me show you another
I
one.
didn't have it.
Let's say A is 10, B is 15, and C is 25. I think that's 3 numbers that work cleanly. 15, 20, 25. All right, 15, 20, and 25. Let's say those are our 3 side lengths. Again, what we're going to do is just add the 3 numbers together. The value of S is going to be 20 plus 15 plus 25, and we cut it in half. What is that? 40, we get 30, correct?
Yeah.
Okay. So now you just take the square root of 30 times 30 minus 20, 30 minus 15.
Are you gonna equal 30?
I don't think so. And when you use your calculator here, square root 30 times 30 minus 20.
Yeah.
It's got to make sure you're closing your
Yeah, it
parentheses.
ends up being
150. That's what I got.
what's the square root?
150. Not necessarily.
I hate that.
Where's your calculator? Do we know? Good place for it for a math class, right?
Good place for home.
Okay. Again, using this formula is going to be ridiculously simple. Okay. Find the perimeter, cut it in half, use it times everything across. Okay. But one of the other things that I know that we are struggling with, though, is the fact of when you wind up with, what do you call it, the ambiguous case. So I want to do another example of that with you guys,
Are we
so,
supposed
so we understand how it goes. What's
to,
up?
are we supposed to check, like, every time it's one triangle?
If you're given an acute angle and the side opposite, check it real quick. All right. And
Check it with the sign.
Yeah.
Okay.
All right, check it with that real fast. It doesn't usually take very long to look into, but even if you're using cosines to start with, if you use the law of cosines to start with, it could fall into a trap where you wind up with 2 triangles by using the law of sines afterwards. It is possible. All I'm doing here is trying to alleviate that possibility by checking it.
So check it no matter what.
Yeah, like I said, it only takes a second. So let's use this one as our example. Angle B. Is 56, little b 13, little a 14. So again, as I start this problem out, what I'm going to do is rough sketch the diagram, see what we're looking at. Okay. Now from here, check real quick. Is 14 sine 56 smaller than 13?
Yep.
It is. Is 13 smaller than 14? Yeah, so right now I know that I'm going to have 2 triangles. The minute you know that you have 2 triangles, you still do the exact same next step. We're still, can I use law of sines here to find A? Yeah. Right. We're going to use law of sines to find A like you would normally. Sine of 56 is to 13. Sine of A is to 14. Now again, in the calculator, let's see, 14 sine 56 divided by 13, second sign of the answer, and I'm getting 63.23. Okay. Or A will equal 180 minus 63. After I get that far, knowing the fact that I'm gonna have to have two triangles in this scenario, just draw the two triangles. So that way you remember to solve for the rest of the parts. Uh, 63, 23, 56, 13, 14. Do we have C? Nothing for it. Does everybody see how you're going to be able to find angle C and it's going to be different both times? So for the triangle on the left, take 180, subtract out the 63, 23, and the 56, and we get 60.77. Law of signs then. And then on the other one, $7.23. Yeah. I'm gonna long sign it again. I can't stress the importance of drawing it out. And that's how you're gonna be able to force yourself to both of them. Yeah,
So whenever you have a second triangle, you just minus the angle by 180.
Yep. You're subtracting the next angle you find.
Yeah.
All right, and then that's how you set it up. Yes, sir.
So why wouldn't it look good, the 14 and 13, because 8 was 14 and
This is just the generic form.
okay.
This just means angle, side opposite, other side.
Oh, okay. I got you.
Does that make sense?
Yeah.
That's I kind of leave it in that generic form because you could write it out all those different ways with all the different letters. Just remember it's angle and it's side opposite and then the other side. All right. And then you just go from there. Oh, and by the way, Quincy Jones is the answer to today's question. In case you did, I knew that one off the top of my head, but I did verify it with the internet. It's on computers.
Slack history.
What's that?
The question on the announcements?
Yeah.
What was it? I paid
It was the whatever most Grammy nominations. I think he has almost 90.
Never heard.
Yep, it is the correct answer. I knew it. My first hour class won a lot. Okay. Let's look at another. Trying to think of the other style that's been messing you guys up. What was the other style that you guys have been messing up on this?
Oh, is there two like
Yeah, the finding the area of the one that you have side angle side.
like I get it.
Yeah, if you have, you'll have to know them both. If you notice the one with side angle side, remember it's just 1/2. That's the easy one. Yes, sir.
Does the sides have to be in a specific order for when you put in the equation?
For this one?
Like, could you put 8, 7 instead of 7, 8?
What's 8 times 7? No, it doesn't matter.
That's for the area, right?
Yeah.
Yeah.
The commutative property works, so it doesn't matter. Just don't use the same one twice, unless it's equilateral or isosceles. One of those. Yes, sir.
What is the SSA formula that
The one you'll probably need to pay close attention to is this one. This is the weirdest of them all. The other ones are pretty obvious. For example, if you're just giving us values, let's say you have A is 95 degrees, little a is 6, and B is 8. Can that happen? Why? Yeah, it's the biggest angle. It has to be the biggest angle because it's obtuse. So right off the bat, you know it's not going to work. The other one where you had the no triangle was in the B sine A. I think it was greater than the A value. That was the no triangle. So if you were just remember the B sine A, if it's less than A, less than B is 2, those are two things you're looking at. And I believe that one is where it goes, no triangle, check. Yeah, then that's a no triangle. And it should be clear enough also with this one, is that you might be given this and that. So you'll be able to see that right away. Right, it's just when the acute angles happen, it's where it gets weird. You were saying something?
Oh,
Yes, sir.
For like the.
No. Sorry.
For like the.
That's for yelling 7 14 times.
That's like 30 times, and then one was to catch. For the B's and A's.
It's not a 9 Inch Nails song. It's not like
What is it for like the 2 triangles and the 3 triangles? If that works, or 1 triangle and 2 triangles.
like 3 triangles? What's that you would
If that works, it's 2 triangles, and then what's 1 triangle? If it doesn't work?
If it's 1 triangle, is if it's equal, and then the or just A is greater than B, little a is greater than B, you're gonna get the 1 triangle. Let me take another ambiguous one because I want you guys to practice this again, just to make sure you guys can set them up right. You will never have an obtuse to a 2 triangle. Take a minute and bless you. Try this one out. We'll give you guys a little. As you get into this, we already agreed that we wind up with the ambiguous case. We've got the 2 triangles. You draw it out, just generic form like you would normally. We have 20, 10, and 11. When you use your law of sines, oops, to get side C, what'd you get for angle C wound up being, what was it, Shay? 22?
22.1.
22.1.
or 21.
Now, to figure out what the other possible angle for C is, we take that and subtract it from
180.
All right. So you get, or 157.9. Okay. Now, the trick is now that you know that you have 2 triangles, which means you're going to have 2 different values for your angle B, and you have 2 different values for your side B. Just redraw the diagram. It doesn't have to be perfect. It's not going to be perfect. I don't want you to try to make it perfect because I don't care. What was the other ones? 11, 10, and 20. What do you get for angle B when you subtract it all out? What is it, 137? Okay. And then the other triangle, again, oops. On the other triangle, you fill it up again with A, B, and C. A is still 20, little a is 10, little c is 11. This is 157.9. That gives you what for B then?
2.1.
2.1. Now, when you solve out now with that to find out little b in both of those, you still will get the small in the triangle on the right. This should be the smallest side length, and then this triangle here should be the largest. So anytime you wind up with the ambiguous case, it means you're going to have an acute and an obtuse angle for the second angle. Okay. What'd you guys get for little b on the left?
19.6.
19 points. Oh, then on the one on the right, you got
1.
okay. That's not. I didn't do the math, but I'll trust you.
I have 11 and 10.9.
No, that's not right. Your math is incorrect. Are you in radian mode?
Yes, I am.
Don't be in radians.
Well,
Okay.
it's still correct. You're
Now-
supposed to be. No, I'm in degree a lot.
And then you press the wrong buttons. All right. You need to have a calculator. One more, or you think you're all right?
I think I got 1 more.
What I want you guys to do tonight is some real basic practice stuff. The quiz tomorrow, I think, is like 6 questions. It's really not that much material to it. But what I want us to look at here is not all of these, because I want you to try and test them as you're going through to look for that ambiguous case, because it does show up. Yeah, I'm sure there's a spare line around somewhere, because you know me, I don't know how to count.
You know you're a math teacher.
Yeah, it's overrated. What I want you to do on this is 8 through 16. Okay? It's a mixture of sines, cosines, and a couple of areas. Oh, I see you guys want some of those too. It's a mixture of sines, cosines, and some Pythagorean theorem to solve the triangle out. Means you can solve for all the missing parts. And then there are 3 area questions. Whether or not it's the side angle side area or your 3 side one to go from there. Okay? Like I said, this should not be horribly scary bad. Okay? Other questions?
What should we do?
You got a little bit of time? I'll just wander around.
So just no work to do.